Welcome everyone. I'm over here in the UK, so I can say good morning. You're most, I guess, in the UK, somewhere in Europe, but probably further afield. So good morning, good afternoon, good evening, wherever you are. My name's Robin Moffatt. I'm a developer advocate at Confluent. So that's Confluent, the people who work on Apache Kafka, not who build wikis. My background is in data and analytics and data warehousing and building systems around that. And I've been working with Kafka for the last few years now. I do lots of blogging, I do lots of talking. Even with lockdown, I've started doing a few YouTube videos. So you can go to those links at the bottom there and go and find out more about this stuff. I do lots of Twitters. My handle is on every single slide because I'm shameless like that. So if you enjoy the talk, if you have questions, if you have any feedback, then do send me a tweet and let me know. Today, I'd like to talk all about Apache Kafka. And Apache Kafka is this concept of an ecosystem and a platform. So this is not a deep dive into Apache Kafka and the nuts and bolts of all the kind of like individual pieces. This is a kind of like Kafka 101, if you like an overview of what is Kafka, what are the pieces that make it up, to hopefully set you up with a really solid foundation to understand what it is and how you can use it, and hopefully how it will benefit you in your projects. Kafka itself is built on this concept of events. So events are these fantastic things that are really, really useful because events comprise two specific things. Events are a notification that something has happened, and they're also a state that goes with that notification. So if you think about a lot of the data that you work with day to day in your systems, whatever it is you're building, whatever domain you work in, a lot of the data that you work with started life as an event. So people think of Kafka as like this streaming thing, and they'll have this mental idea of like, here is this stream of things, and then over there, the majority of the world is like this other just like static data. But if you stop and think about how that static data was born, it probably started life as an event. And many, many different things are events. You have human-generated events. You have people interacting with our businesses. You have people buying things or clicking on our websites. You have inventory moving around between your warehouses. And these are events. There's a notification, someone bought something, and there's state. What was it that was bought? What was the item? Where was the shop? What time was it? You've got an event of things moving around warehouses. The notification, something moved. The state, what was it? Where did it move from? Where did it move to? But it's not just human-generated events. Machines generate events as well. You have IoT devices with all the different readings being sent out. You have network switches and routers and firewalls, a huge number of events happening in those. And you also have the applications themselves that we're building. You write an application and you write some error handling code and you say, well, we're going to hit this thing here because there was a problem. That is an event. There was a problem. There's your notification. And then you've got the state. You've got the stack trace. Here's the particular problem we hit, here's the error message, here's the stack trace. And so applications, they'll probably chuck out a message to a log file, but those things that we're chucking into a log file are events. So events, if we stop and think about it, are pretty much everywhere. And there are a few exceptions, but most data that we work with starts life as an event. And then like the implementation detail of how we store it is how a lot of us then think about data. Oh, well, my data sits in a database, it's not an event. Well, it actually is. It's just you've decided to store it in a different way. You've like aggregated it up away from the events. But it started life as an event. And these events are very, very powerful. There's a lot of good stuff around like event-driven systems and event sourcing, because people realize that if you have events, you can rebuild state. You can drive systems in an asynchronous, loosely coupled way by saying, if something happens over here, this thing needs to respond. But we're not going to tightly couple them together. We're going to start pulling this thing to say, have you done it yet? We're going to do it the other way around. We're going to say, this thing happened. Now other people can opt to know about it. So events are really powerful. But how are we going to actually use them? Or as the buzzword would say, how are we going to leverage them? But we mean use. How are we going to take advantage of these fantastically powerful things? We need a platform on which to build with them. So we're going to start small. We're going to start with an event. But obviously, events happen continually over time. So now we've got lots of events. So we need to think about how we're going to capture these events, how we're going to work with them. And for the moment, we're going to think of an event simply as a key value pair. We're going to drill into this concept a bit later on in this talk, but for now, just bear with me. We're just going to think of an event as a key value. And this could be an order being placed, it could be your application throwing an error, it could be a temperature reading from a device. It's just an event. So we store logs in this very, very simple but very powerful idea of a log. And this log is not your application log file that's like log.txt, we use log4j or whatever. I suppose that is a log, but a log that I'm talking about here is a much more foundational, fundamental concept, which is where we say this log is where we put our events and we append them as they happen over time. So something happens, we write it onto the log, and it's append only. It's append only, and it is immutable. So because it's immutable, that's very, very powerful, because we can say, here are the things that happened, and we know that none of them have changed. So if you imagine having a conversation with someone and you say things and someone else says something, and maybe you get into an argument and you say some heated things that you probably wish you hadn't said with hindsight, but you've said them. It is immutable. That event has happened, that fact has been said, that sentence was said in anger, and you can't go back and change that. It is immutable. All you can do is like hopefully put down another event to try and counteract that and apologize and undo what you said, but it has been said, it is immutable, and so is a log. So a log is like a commit log of all the things that have happened of our events. So events happen over time, and it gives us this idea of the log. So the log is what underpins everything that we're doing here. So it's a very simple but a very powerful concept. So if we think of this idea of taking all these events that are happening, we store them on a log, at some point we're going to say, well, that's not necessarily manageable, just have like one log with all these different types of events going on, because we've got lots of different types of events, we've got lots of different entities. So we say, well, okay, let's take this log and we're going to carve it up and we'll call it topics. Topics is a fairly well-known term. If you're from the database world, like I am, you probably think in terms of tables. But here we've got things like clicks on our website. So people are clicking around our website. Those are events. There's a notification. They did a click. There's state. What was it they clicked on? Who was the user? What's their user agent? And so on. We've got orders coming in. So if someone placed an order, there's our notification. Or the order shipped, there's a notification. Here's the state around it. We've got another example topic here called customers. And people don't always realize this first off. They'll kind of like think, well, clicks and orders, those are obvious events, and I can kind of easily see how those would go onto a topic and we'll store those in an event platform. But customers are like what we'd call reference data or lookup data. And does it make sense to put those into a series of events? But if you think about it, customers or any kind of data like that are created through an event. It gets created, there's your event. And it gets updated, and it gets updated again. And so a customer registers on our website, there's your create and the state that goes with it. They move house, they update their address, there's your event and the state that goes with it. And if you capture all of those different events to do with your customers or your product reference or whatever, you end up with a series of events that you can replay to give you the state of that particular entity. So in data warehousing analytics, we talk about facts and dimensions. And it's the same kind of thing here. All of these things live very, very naturally when broken down into events, because with all of these things, we can replay them to rebuild state when we want to. So we cut up our log into what we call topics, and this gives us the ability to arrange our data into kind of separate entities to make it appropriate for use. We're going to cut it up one further time, and we're going to do this as a way of giving us a system which is highly scalable and performant. So each topic can have one or more partition. So partitions take that topic and they cut it up and they say, well, within this topic, we're going to have maybe 3 different partitions. And the reason for doing this is that we can then spread that data across different nodes, because Kafka itself is a distributed system. We'll talk about that in just a moment. So we can distribute the data across different ones by having separate partitions. But you can also use it for parallelization of reading and processing that data. So instead of just having like one log file that you can only read through sequentially by one user, instead we split it up into topics and partitions within those topics, and now we can process that data at very, very high scale. So we started talking about getting data in, we've started talking about getting data out. So let's talk about this concept of PubSub. First off, publishing the data to the topic. How do we get that data? How do we get these events into a topic? We use the producer API. So Apache Kafka, it ships with a Java client, and there's other client libraries for C, C++, Python, .NET, Go, and like every single common language there is. If there isn't one for your language of choice, or you'd rather not use that, there's also a REST API you can also use for producing data. So whatever it is you're using, there's always a way to get data onto a Kafka topic. As we said, the data goes on to the end of the topic when we produce it. Those events get appended to the end of it. If we're talking about using a producer that's going to write across different partitions, it will handle allocating those different partitions. The producer code looks something like this. If you're using Java, we say we're going to spin up a producer, we're going to connect to a broker, and we're going to send messages in this particular way. So at the beginning, I talked about events, and I said, for now, let's just talk about events as these key values. Now let's drill into a little bit more about what we mean about that. Because Kafka itself just treats those messages as key value bytes. It just says you've got a key part of the message and you've got a value. And that could be like foo and bar as your key and your value. It could be your key is 1 and your value is a hugely complex schema. Like a tweet is a good example of an event. It's got a key, which might be the tweet ID. And then the value of a tweet is like, if you've used the developer API, you'll see like a hugely nested structure of like all sorts of stuff. So the value itself isn't just like one single value. The value itself could be hugely complex nested if you want to. You don't even have to specify a key. And if you don't specify a key, when we use the producer API, it will just round robin those messages evenly across however many partitions you've got in your topic. So you end up with a nice even distribution, but within partitions, we have this guarantee of ordering. So when you write data into a partition, you're guaranteed by Kafka, by like the way it's built, that when you read that data back, you'll get it in the strict order that it was written to that partition, which is really, really useful because we've got this immutability guarantee that stuff's not going to be changed once it's being written to it. We've also got this strict ordering guarantee, which means that we can say, well, I'm going to take this particular instance of an entity, like a particular customer. I'm going to read back all of the events that we've got relating to that customer or this order or whatever. And I know I will get every single one, and it's not being changed along the way because it's immutable. And I know that I'll get every single one in order. But that only applies within a partition. So if we're doing that kind of thing, we need to make sure that we've got all of the data relating to our particular instance of an entity that we're interested in on the same partition. And that's where keys come in, because if we don't set a key, the data just gets round robin, evenly distributed across the partitions, which might be fine, but you might actually want to ensure that we do have that locality in the partition for each instance. So for that, we set a key, and then Kafka Producer API uses a hash of that key to make sure that every key value ends up on the same partition every time it gets written to. So you then end up with the data spread across the partitions, and this is where choosing your key appropriately comes in, because you want to make sure you set it based on, I want all of these events to be strictly in order for a particular customer or something, but you also want to make sure you don't end up with lumpy distribution. So if you said, I'm going to partition it, I'm going to use a key of location, that might not be so good because you're going to end up with like one partition that's hugely overpopulated. Maybe if you break it down by city, like the capital city will have loads of records, and like really small, low populated areas will have much fewer records in their partitions. So you need to pick it appropriately as well for bearing in mind how you're going to spread that data out. So this producer API, it's a client library, it's an application that we write. It gets the messages onto the topic. It handles talking to the brokers. It handles the partition logic. There's various different languages. There's the REST API as well, if you want to use that. So we've got the data onto a topic. How do we get the data out? And this is a little bit more complicated for good reasons, because it's very, very powerful. But producing data onto Kafka is basically like, where's my Kafka cluster? And here's the data, and off you go. We're going to talk about serialization later. That's where it gets a little bit more interesting. But for now, producing data, chuck the data, and we're done. Consuming the data is really interesting. It's very, very powerful what we can do here. When we go to Kafka and say, I would like to read a message, that access is only sequential. You can't do like random access and get like, give me the value for all of these particular keys, or like do searches on it like you would do in a database. It doesn't work like that. We've got a log. We've got this immutable append only log, and we can seek through that log to a particular place in it and then start scanning through and reading those messages. So our first consumer comes along and they connect to Kafka and say, I would like the messages from the orders topic. And Kafka says, okay, here are all of those messages. Now, if you're thinking of Kafka in your little mind model of technologies that we've got to try and comprehend these days, like all these different terms and stuff like that, if you've got Kafka bucketed in that same area as transient message queues, then you need to scratch that and like reevaluate, because Kafka is actually an event streaming platform in its own right. It's not transient message queue. That's one of the most important things to understand. It's a distributed commit log that we can send messages to and we can read messages from. But when we read a message, it is not deleted. Even if another consumer comes along and says, I would also like to read those messages, Kafka doesn't say, oh, well, 2 consumers have read that, so I must be done with them, I'm going to delete it now. Kafka says, you gave me that data, I appended it to the log, it will stay on that log until you tell me to get rid of it. So regardless of what the consumers have done, we say to Kafka, this particular topic here, it's got information about clicks on the website. I'd like to keep 7 days worth of that, because that's kind of the business use case for processing that data. This topic of orders, I'd like to keep that for 10 years, please, because that's when we're going to need to use it. This topic of customers over here, we're going to keep that forever, because we want to have that as our system of record for all of our customers. You know, when they're created, updated, we can use that and we can replay it to build the state anywhere else we want to, but we're going to keep it forever. So when the consumers come along, they simply say to Kafka, I would like to read data from this topic. And Kafka will either say, okay, here's every single new message as it arrives, or it'll go back to the beginning of the topic and say, here is every message that I've stored and scanned through, and here are all of those, and then here are the new messages as they arrive as well. Consumers can even say, well, I've read those ones from here, and actually I'd like to replay them. So my application was running, everything was good, and then downstream of my application, something went bang. We realized there was a bug in the code. I would like to rewind. I would like to skip back to a particular offset. So like go back to offset 42, or I would like to go to an offset based on timestamp. I would like to start reading messages as of yesterday at 3 o'clock. Kafka says, okay, that corresponds to this offset. Here you go. Here are the messages since yesterday at 3 o'clock. And then we keep on scanning through until we get to the end of the log. And then the consumer keeps on reading those new messages as they arrive. So when a consumer reads a message, it is not deleted. Consumers don't even have to exist. They don't even have to be in the thought of yet when we write data to Kafka. And this is one of the very, very powerful things, because we can then say, I subscribe to this, or I don't subscribe is a silly term to use. I agree with this idea of events being very, very useful and very, very powerful. So I'm going to embrace this, and my application or my system is going to say something happened. Someone clicked on something, someone bought something. I'm going to produce that event to Kafka, because that's probably going to be something that someone else wants to know about. And that's all the producing application has to do. And now your consumers can come along, and either they were built specifically for that particular use case and it gets produced and then they consume, or it could be a consumer comes along next week or next month or next year and says, oh, we've got a topic of orders, that's really useful, I'm going to go and read those. So long as we've set the retention appropriately on the topic, anyone with the appropriate security setup can then come and read those messages. So consumer, here, again, here's the Java example. We connect to the broker, we poll the broker for a particular topic, and we receive those messages. So a consumer will read data from the topic. It will read across multiple partitions if the topic is partitioned. We can have separate consumers which are completely independent from each other. Again, it's worth pointing out, because Kafka is storing this data, if one consumer falls over and hasn't read some stuff, the other one is not affected. That data stays there as long as we've told it to retain it, and then it gets aged out. So other consumers aren't going to suffer if one of them has stopped. And in other systems, things would start to back up, and you'd end up with these huge bottlenecks because one of them hadn't read the messages and the system couldn't cope with all these messages building up that had to be consumed. Kafka works completely differently from that. Kafka also lets you consume messages in parallel. And this is where the partitioning thing comes in. Because at the moment on the screen here, we've got 2 consumers, C1, C2, the blue one at the top, the green one at the bottom, separate, completely independent applications. Each one reads all of the data in the topic. What if we need to process that data faster than a single consumer can keep up with? So C1, the blue one at the top of the screen here, Maybe that's some kind of fraud processing thing that as orders get placed on this source topic, it needs to process them, it needs to score them, write them back onto a separate topic, there's another system to pick up and do something with. And we've got a single instance of that application, and it can't keep up with the throughput that we need to meet our SLA for this particular service that we've written. And we scale the machine and we put more CPUs in and give it more memory, and we still can't keep up. So you say, okay, well, let's scale it out. Let's add in additional instances of that consumer. So now we've still got two logical consumers. We've got C2 at the bottom, we've got C1 at the top, but C1 has got multiple physical instances of that consumer. And Kafka handles this for you. You simply say, here is another instance of my consumer, and Kafka's got this protocol as part of it. So a nice little slide here from my colleague Vic Gamov. The idea is you've got your consumers, they're little birds in the nest cheeping away. That nest forms what's called a consumer group. So a consumer group is this logical grouping of a set of instances of a consumer doing the same logical task. And then Kafka itself acts as mummy bird, and it's called the consumer group coordinator. It says, okay, you're an instance of this consumer group, you get data from this partition. You're another instance of a consumer within this consumer group, you get data from this partition. So you end up with the data allocated across based on the number of partitions that you've got, the number of consumers that you've got, and it will evenly distribute that work. So if we've got 4 partitions and we've got 4 consumers, then each consumer within that consumer group gets data from 1 partition. If we had 4 partitions and 2 consumers within the consumer group, each consumer would get 2 partitions. And Kafka understands that you've got these processes running within that consumer group. It'll keep an eye on them, and if you lose one of them, then it'll say, okay, well, we've now got a partition that's not being consumed, it's not being read from, and we don't want to do that because we've got guarantees in place that all of this data is going to get read. So then we say, well, okay, one of the other consumers will get allocated work from that partition. So Kafka does all of the heavy lifting here for you that within your application you may have to do otherwise. You start writing like, how do I manage scaling the consumption of this workload and all of these tricky things. You simply say, here's my consumer, it's part of this consumer group. Kafka says, okay, you get this, you get that. So the consumer API, very, very powerful, a little bit more complicated than the producer API. It's still a client application. It reads the messages from the topics. It lets you scale your work horizontally. You just add in additional consumers, and again, different libraries as well. We need somewhere to store all of this data, and we're going to store it on brokers. So far we've been very, very abstract. We've talked about logs and events as like these key value things. Now we're getting into the nitty gritty of like, well, where's this stuff even live? Like, I'm going to go and try this out. It sounds brilliant, but where does it even live? What process do I need to run? Kafka itself has a broker process. That's like a JVM process that you spin up and you can see on your machine. So the Kafka Broker is where this actually all happens. And it's a distributed system. You can run a single instance of it if you want, but that's not really distributed, it's not really scalable, it's not really fault tolerant. So a typical production deployment will start off with a minimum of 3 brokers. And each broker will contain some of the data, which is why we partition it, because we can then spread it out across those different brokers. You don't have to partition it, but then you'll see from the previous example, you're not going to be able to scale very far with it. So each holds some of the data. We've got 4 partitions. Those partitions are going to get spread across each broker. And in a standard distributed systems fashion, we're going to hold redundant copies of that data too. So we've got the leader partition exists on the different brokers, and then you've got follower copies of that partition data, all for redundancy, spread across the brokers as well. So here we've got 3 brokers. We've got a kind of like replication factor of 3, so it exists on 3 different brokers. If you had 7 brokers, you would have some without data from some of those partitions. It just means that you've got that room to scale if you want to. And if you have other topics, then their data will be spread out across them. So the example here is a single topic with 4 partitions spread across those 3 brokers. And if you lose a broker, if things go bang or someone unplugs it from the wall or something like that, because we have redundant copies of the data, one of the remaining brokers can step up and say, well, that's fine. I will take over leader responsibilities for this particular partition. So it's very, very powerful. It means that you can scale out as you need to, and you have this built-in redundancy and failover provided by default. So let's actually have a look at this in practice. I'm going to show you a very simple demo, and then we're going to go and talk out more advanced things that you can do with it. So the example I'm going to show you here, all the slides, I should have said, all of the slides and stuff, they'll be online. Follow my Twitter, I'll be tweeting them, or I'll put them on the Slack channel afterwards as well. But all the demos are online as well. So you can actually go and try this out for yourself. It's just based around Docker and Docker Compose. So there's a cheat sheet, which is when I keep on looking down like that, that's what I'm looking at. And you can follow the demo through and try it out. So the first thing that we're going to do is we're going to spin up a producer. And here I'm using a command line interface called Kafka Cat. I'm more of a kind of like data engineering type person than like a full-on coder. So I tend to kind of like the command line instead of writing applications. But if you prefer using Java or something like that, you could go and imagine your Java code here or Python or whatever. It's a producer API. Okay, so it's a tool called Kafka Cat. It's going to connect to Kafka Broker, and we're going to produce messages to this topic called test. So we hit enter, and then we worry because it's a live demo and nothing's happening. But it's a producer. It's saying, well, give me some data to produce. So I've said here -k colon because we're going to use colon as a separator between keys and values. So let's send it a message. There's our key called 1. I'm going to say, hello, NDC. And we've sent 2 messages to Kafka. We've sent them to the topic. So now we can read them from the topic. So I'm now going to spin up a second process. So in the bottom of the screen here, we're going to create ourselves a consumer. So pretty much the same command. Here's my broker, here's my topic, and then -c because we want a consumer. There's our 2 messages, hello NDC. You'll notice there it's just shown the values of those messages, not the keys as well, because that's what it does by default. And if we say send some more messages, so like, I wish I was in Oslo, you can see those messages coming across. As we send them to the producer, they get consumed. They get consumed, but they don't get deleted. Super important point, and the reason I labor it, like if you're familiar with Kafka, apologies for going on about it. If you're not familiar with Kafka, it's a really, really important point to get. So I'm going to keep on laboring that point. Because we've consumed the messages does not mean anything to do with when they're going to get deleted from the topic. They're completely decoupled concepts. They'll stay on the topic for as long as we've told Kafka to keep the data on that topic for. So we can read the data again. So in the bottom right of the screen here, again, we use Kafka Cat. We're going to use a consumer. And this time we're going to use this here, which basically says format the data as it comes out. So it's going to read the messages and it's going to say, okay, we've got data from the test topic. It's from this particular partition. Here are the offsets of those individual messages. Again, we can see we've got the values and you've got the key. So you've got the key to the messages, which is also being displayed. And if we send some more messages now, so like this one doesn't have a key. So we send a new message there. It doesn't have to have a key. You send that across and both the consumers get that message straight away. And you can see down here where we're showing the key, it has a blank because we don't have a key. And we can send more messages and you can see as we send those messages, they're going straight across to those consumers. If we go to the consumer here and clear that so we can see what's going on, we can also say, well, I would like to read, instead of from the beginning of the topic, just start at this particular offset, just start at offset 6. So we know that we got to offset 5 last time. We've decided that we want to, we got to offset 10 last time, and now we want to reprocess. So we say, okay, we're going to go back to offset 6. This is okay. Here's the messages from offset 6 onwards. In saying that, I realize I've omitted a very, very important detail, which is that as consumer applications, it's not our responsibility to track the offset. Kafka tracks the offset for you. So as a consumer, you read the messages and you say, yeah, I've processed those messages. Kafka stores the offset for each consumer. So when our consumer reconnects, Kafka says, okay, this is where you got to last time, and off you go. And as a consuming application, you can optionally say, never mind that, I would actually like to start from this point here. But Kafka tracks those offsets for you. It's a really important point to have made. We've got a producer, we're sending nonsense over to a topic, we're reading nonsense from that topic, it's just key value bytes, remember? So I could send some JSON over here, so you can say, like, here's this message, I'm going to type in some JSON, it's like the most simple JSON message in the world. So we send that over, you can see you've got the value picked up down here, over on the right-hand side you've got the key value, but we're just sending bytes to the Kafka topic, because actually we need to think about serialization, and we're going to talk about that in just a moment. What we're going to talk about next, though, is now that we've got this concept of a producer and consumer, what are we going to build with this? and what are the things that we're not going to build with it. So let's head back to the slides. So I can see a few questions coming in, and that's brilliant. If I get a chance at the end, I will take the questions from here. If you want to, I would suggest copy and paste them into the Slack channel, because then I can answer asynchronously, as all good systems should, and I can actually go through those and make sure I get to them. As I say, if we get time, I'll do them on WebEx as well. But feel free to put them onto the Slack. I'm off on the Slack if you want to tag me, but I'm track 7 room as well, so we can do them there. So that was the brief demo. As I say, the code is online. I'll share the link to that afterwards. Produce data, consume data multiple times, consume data, reconsume data. That's what Kafka lets you do. And it's all pretty good. It's a very, very powerful, it's a very scalable system, but we've only just really got started. Or to put it another way, I've not even finished yet. Because the data that we're getting in and the data that we're getting out, you start to see the same kind of patterns that people adopt and want to do with this. Because they say, I've got a Kafka. I've heard this Kafka thing is good. I'm going to Kafka all the things. And now that I've got this Kafka, I would like to Kafka lots of things. I would like to get some data from my database into Kafka because I want to drive an application with it. Or I've got data in my Kafka and I would like to push that down somewhere else. I'd like to send it to S3. I would like to say, Kafka stores my data for me. As well as sending it to S3, I'd also like to send it to HDFS or to any number of other places. Or someone says, well, you know that kind of like big, ball, hairy monolith that we've got that's underpinned by a database? We need to replace that. It's kind of like, it kind of sucks, and it's like it's old, or it was written by someone else, and we didn't change it because it's all like this messy thing. We'd like to move, or we'd like to evolve to a much more flexible architecture. We're kind of going to the microservices route, and we would like to take what's happening in that existing application and use it to drive our new application. We're not going to go big bang because we know how those kind of projects usually end up. We'd simply like to say when stuff happens in our existing application, we would like to use those events to drive our new one. And if you think about events and what they are, events actually live in databases as well. So we've got our existing monolith and it's using a database. So like it's an e-commerce system. Every time someone creates an order or updates a customer or does something, it writes it to the database. And in the database, we've got order tables and customer table, all this kind of stuff. But a database itself is built on a append-only distributed, append-only commit log, distributed maybe. But we can take those events that happen in the database and we can capture them and we can stream them into Kafka. And because we can stream them into Kafka, we can build new applications driven by events in Kafka, populated by stuff happening in the database. And now we can start to chip away at what's happening in our existing application. We can say, well, when this new order gets created, we're going to run some order processing, like a fraud detection thing or something over in our new application, driven by those events from the source one. Start to migrate over time bits and pieces of functionality whilst the existing one is still running. But whatever it's we're building, whether we're starting to migrate things, whether we're building pipelines from like databases to S3 or whatever, we're going to have to get data between these systems. We're going to have to get data from the database into Kafka, from Kafka to S3. And people will probably say, well, we've got a producer API. We've got a consumer API. I shall write myself a program. And I will go to the database and I will pull the database and I'll kind of like pull those messages in. And then I realize I can't keep up with a single instance doing it. So I'll have to scale out. And I'll have to work out how I distribute that workload across having scaled it out. And I've solved that. And now I need to make sure if one of them dies, another one can pick up because it's tracked where it's got to and track the offsets. And then we also want to use the same thing to be able to pull in data from other sources like message queues or flat files. And we also want to push data down to target systems. So why don't we make this thing kind of like modular, and we can kind of like, we can make a framework. And we can say to the business, like, we're going to solve all your problems, we're going to build a framework. And this sounds like a lot of fun to do, but it's a trap. Because building frameworks is a whole bunch of fun, but it doesn't differentiate our business from any other. Just because we've learned how to write data from Kafka to S3, that's what everyone's doing. That's us being able to do that doesn't bring us forward beyond the competition. And also, sorry to say, it's a lot of fun to build these frameworks, but the fun has been had for you. Apache Kafka includes its own framework for integrating other systems into Kafka, and it's called Kafka Connect. So Kafka Connect is the integration API, if you like, for Apache Kafka. And it lets you stream data from systems into Kafka, from Kafka down to other systems. And it means that you can do all of this integration. And you can do all of this integration from databases and message queues and flat files down to data stores and NoSQL and cloud object stores and wherever you want to get and put your data as either just like flowing through Kafka as a pipeline, or driving applications in Kafka, or taking the results of applications produced into Kafka down to other places for analytics. You can do all of this, and it's driven by configuration. You simply say, here is my JSON. It declares where I'd like to get my data from, where I'd like to put my data, which topics, and so on, and off we go. And Kafka Connect is pluggable. So you can say, I've got my connectors, which talk to particular technologies. I've got my converters, which handle serialization, which I promise we are just about to get onto. You can even do transformation work on the messages as they pass through this pipeline. You can say, I'm going to ingest from the database, but I'd like to drop out these particular fields before we even send them to Kafka. I've got these fields here. I'd like to change their data types. I'd like to change the schema. You can do this as it passes into Kafka, or for a sync connector, as you take it from Kafka and write it downstream. You can go to Confluent Hub to download all of these different connectors and converters, and just search for your particular technology and do a command line install, or click on it to do the installation, and off you go. To run Kafka Connect, it's just a JVM process. It doesn't run on your brokers. So on your broker machine, that's like where your broker runs, and you'll have separate broker machines. Kafka Connect runs separately, unless you like prototyping, in which case it all runs on your laptop anyway. But for an idea of how you deploy it, Kafka Connect runs separately. It's a JVM process within which the different connector tasks run, and you can scale it out. So Kafka Connect, under the covers, it's using producer consumer APIs, so it can also benefit from Kafka's ability to scale and have fault tolerance and reallocate work as it needs to. And if you lose a worker, you scale this out, it's fault tolerant, you can bring the work, or Kafka Connect will bring that work back into a place where it can run if you lose a worker. So Kafka Connect is this integration API for Apache Kafka. Got a whole bunch of different connectors that you can plug into it. But we now need to think and finally address this point of serialization. Because I started off this talk by saying, well, let's wave our hands a little bit and just pretend that events are key values. And kind of we'll brush the rest of that detail under the carpet. Now is the time to pull back that carpet and actually examine what's going on here. What is a key value message? What are we actually doing with this? Well, key value bytes are what we send to Kafka. And as developers, as software engineers, as whatever our job title is today, we need to work out how we're going to serialize it. If we're reading the data, we need to know how we're going to deserialize it. And hopefully, we don't just play eeny, meeny, miny, mo between one of these different terms and pick the one that's got the shortest abbreviation, because that'd be a terrible idea. We need to understand what are our options for serialization, what are the implications of picking the different ones. And this is where schemas come in, because schemas and serialization are very much intertwined. Take a step back for a moment. Think about how services, without Kafka, as dreadful as it sounds, how services communicate when they're synchronously coupled. One service says, I'm going to send this data to you, and the other service says, I'm expecting to receive that data from you. And I'm expecting to have these fields in it, and these types in it, and these values, and so on. And so schemas have services have a contract between them, and this contract is their API. And it says, this is what I will send, this is what you will send, this is what I'll send you, this is what I will expect to receive. And you don't have to do this synchronously, like REST or gRPC or whatever you're going to use. You could use an event. You could say, actually, we'll use Kafka to kind of asynchronously couple our services together. So instead of saying, I will send you this, I'll wait for you to send me something back, you say, okay, someone came to our website and they created a profile, or they updated their profile. So I'll put that event onto a topic. I'll put that onto the queue. Another service says, well, that's good. I will read that. We can start acting asynchronously because they don't have to be tightly coupled together. So you get a bunch of benefits from making that more loosely coupled. So we've got topics as the way of transferring that data between them. So we've got a website, and it's an insurance website. So someone updates their profile, and the quote service takes that update, and it does some scoring. It puts it back onto another topic for the profile service to receive. But the way that happens with Kafka, almost always, is that you'll start off with an initial use case. And always start with a use case. Never start with it just because it sounds cool and you heard about it at a conference. Always start with a particular use case that's appropriate for it. But people will say, well, okay, we're going to use asynchronous coupling between these two services because it makes a lot of sense. Every time someone changes their profile, we'll put that onto a topic, and then our quote service will subscribe to that topic, and it will receive those updates. But then someone else says, oh, you've got a topic with information about customers every time they change their details. That's really useful. because we want to take that information and we want to persist that down into our database. We're going to use that topic as the system of record, and any changes, we're going to reflect that in the database over here. And we're going to take that and we're going to do some stream processing on it over there. And this is the beauty of Kafka, because the profile service is doing absolutely nothing different. It's just continuing to produce events onto a topic. The quote service is doing nothing different. It's just continuing to read events off that topic. It's just that other teams can take advantage of that same data in a loosely coupled way to come on and say, well, that data is useful. We will also use it. But now what happens is that we've got this data that's being interchanged between these services. And at the moment, we're saying, like, we've got a user ID and it's an integer, we've got an address and it's a varchar. What about some of the other fields? What about the time at which the profile change was made? And to start off with, we use a big int, and it holds the number of milliseconds since 1970, since the Unix epoch. And the team that came along said, we're going to put this into a database. That's useful. Okay, it looks like it's a number, so we're going to model that into the database. And the stream processing team say, well, that's fine. It's a big int, and we're going to process that. And that's fine. And everything gets on nicely. But then the profile service and the quote service sit down together. They say, oh, yeah, instead of a big int, we're going to use a varchar, which is probably a bad idea for timestamps, but we're going to do it anyway. So we're going to change. So the profile service says, okay, that's fine. I will now send across the timestamp as a varchar. And the quote service, like, they knew about this because they sat down together. It's okay, we're going to expect that. And we're going to move fast, and we're definitely going to break things. Because now we're sending across what was a big int as a varchar. So all of this lovely loose coupling that we've done, all of this benefit that we've got of building around events, now, if we're not careful, we're going to undo all of that. Because if we're not careful, we start using this as our message format. And someone says, oh, yeah, serialization. Okay, well, let's just put like tab separated. Like, what's it really matter? I don't understand the fuss. This is my warning. Understand that fuss. It really, really matters. If we eyeball this, we can see there's an address, there's probably social security. We have no idea what the field names are. We have no idea what the separator is. We can probably guess. We have no idea what the data types are. We could probably guess. And so instead of guessing at it, we're going to do invariably what humans do, which is go and phone up another human or email them or Slack them or tell them and say, what's this field? What's this data type? What are these things here? And by the way, if you change any of this, please tell me. And because we're an organization and we're big and we're enterprise, we'll have a change review board. And now instead of moving fast and breaking things, we move really, really slowly. And we probably still break things. And we tightly couple our systems back together. Wouldn't it be great if there was a different way of doing it? It turns out there is. So instead of playing eeny, meeny, miny, mo, and saying, well, we've got to serialize the data, Kafka's just bytes, and like, we'll just pick one of these, we're going to pick one of these with a lot of conscious thought. We're going to say there's some really good ways to do it, there are some mediocre ways, and there are some fairly crappy ways also. We're going to use a serialization method that has got strong support for schemas, that lets us enforce schema compatibility guarantees, that lets actually check when we write data, is that going to break things? So we're going to say when the producer comes in, it's going to serialize data, and we're going to use Avro, we're going to use protobuf, we're going to use JSON schema. The schema itself gets stored in the Confluent schema registry. The producer can enforce a compatibility check and make sure that what we're writing is compatible with that schema that we've declared, and it puts the data onto the topic. The consumer comes along. Not only does it make sure, does it say, well, this is great because now you're not sending the random things which is just going to break me because we've got compatibility guarantees. The consumer can go to the schema registry and say, what's the schema? Instead of having to phone someone up and that person's on holiday and we're not quite sure who else is managing it and so on, the consumer goes to the schema registry, which is a computer who doesn't go on holiday, and it says, what's the schema for this particular message or for this particular topic? It says, well, here is the schema. And the consumer laughs and sings with joy because this is brilliant. Because the consumer can now go and do things, and it can say, well, I'm a Kafka Connect consumer. I'm going to take that data. I can now go and declare a database table because I have the schema, and I can go and populate it. I don't have to go back to the people who produced the data. The schema registry itself stores its data within Kafka, which is pretty cool also. To use it, you use the appropriate serializer within your producer code. So schemas and schema registry is so, so important. Kafka itself has a concept of like, we can do all this scalable, fantastic PubSub and it's persistent and that's great. It's very, very powerful. But there are too many examples where people have started at that and thought, this is great, I get Kafka now, I'm done. See you later, guys, and I'm off to go and build this. And if you don't have the other stuff around it, like let's have some good forethought about serialization, about schemas. You end up having to refactor an awful lot 6 months down the line when you realize the pain that happens if you don't have strong support for schemas in what you're doing. I want to finish up with the last piece of the puzzle within the ecosystem, or the last big piece in the puzzle within the ecosystem. Because these applications that we're building, these consumers that are coming along and saying, this is great, we've got schemas and we know how to deserialize the data, and we can read that data and this is happy days. What are we actually doing with those messages when we read them? We're probably doing a fairly common set of patterns that can be distilled down to a few specific things. I want to give you an example with a specific set of data instead of just talking in abstract, hand-wavy stuff. Let's imagine we've got a factory and we've got robots on that production line. And within those robots, we've got lots of lovely instrumentation and IoT type stuff going on. So every step of the way, we're getting sensor readings with timestamps and all these different sorts of values. These are a perfect example of events on a topic. And we're going to read those events and we're going to do things with them. But what are we going to do with them? We're going to do a fairly limited set of things. We're going to do things like saying, I want to read this and I want to filter it. So read these things in. If it matches this condition, go and put it somewhere else or go and do something. I want to take these things in and I want to aggregate them. I want to count how many of these things happened within a particular time frame. Or I want to do something, I want to aggregate it and I want to alert on it. So count these things, and if it's over this amount, or take an average, and if it's over this amount, go and do something else. Or I want to take these things, I want to process them, and I want to push them downstream for analytics or whatever else. These are the kind of things that fit into a lot of applications that we build, and are a good example of stream processing. We've got a stream of events that's being built up over time. These events arrive sequentially over time, and we want to filter it. We want to process it. We want to aggregate it. We want to do stuff to it. We want to say, okay, we've got a stream of widgets, and widgets have got colors. We would like to filter that stream of widgets, and we'd like to say, I want to create a separate stream of widgets which are red. Any yellow widgets, I'm going to ignore them. The red widgets, we're going to go and put onto a separate topic to go and drive a special red widgets microservice that's responsible just for doing something to do with red widgets. That's fine, and we can do that, and we can do that using stream processing. There's different ways to do this, and within Apache Kafka, you have a stream processing library called Kafka Streams. And Kafka Streams is a Java API, and you bring it into your Java application that you're writing, and it lets you do stream processing. It lets you say, take messages from here, filter it for there, and go and put it over there. And so it gives you this framework, which means that you don't have to go and build it. You don't have to go and deploy a separate set of stream processing things over there, like separate technologies, so like feed and water in a separate different way, and make calls out to them. You can do that stream processing within your application. You write a Java application, it's responsible for driving a dashboard or responsible for servicing user requests. How many things of this thing have happened recently? Take this thing and draw this picture on the thing with an aggregate of that or a filter of that. You can do that stream processing within your application that you're building instead of having to call out to separate things. So instead of just consumers, we end up with a set of stream applications. And just as you deploy your applications in a certain way that's specific and works for you, you test and you deploy your stream processing applications in exactly the same way. It's just a Java library that you're bringing in. But not everyone writes Java. There are plenty of people using other different languages or who aren't really coders at all, like me. In which case you say, well, wouldn't it be nice if there was a different way to do stream processing that you could express in a more abstract way, using a declarative language, maybe like SQL, for example. This is where ksqlDB comes in. So ksqlDB is built on top of Kafka Streams. It's part of Confluent platform, and it means that you can use SQL to declare what you'd like to do with your streams of data. I've got a stream of widgets. I would like to create a new stream, a new Kafka topic, populated by these widgets matching this particular predicate. And that's a proper working example of some ksqlDB code there. There's no boilerplate around it to deploy. You take that and you send it to the server using the command line interface, using the REST API, and it'll go off and it'll run and it'll continually populate this new Kafka topic using the statement you've given it. So if we apply this to the examples that I showed you earlier, some of the patterns of what we want to do with data, we can say, well, I would like to filter this particular stream. I would like to know about widgets that fall over a certain weight category. So we say, well, select everything from this stream where the weight is over 120. So I'd like to do some counting. I would like to know how many widgets we processed by production line over time. So we'll select count from here. I would like to take an average of this, and we're going to apply an alert on it. We're going to have clause on there. So you can do all of these things using ksqlDB. And using ksqlDB, you can also take messages from a stream and push them down somewhere else using Kafka Connect. So you've got this stream of data coming in, filter it and process it and join it if you want to, and then go and put it into S3 or into Elasticsearch or HDFS or Snowflake or any other of the numerous places that Kafka Connect integrates with. So these are examples using ksqlDB. You can do the exact conceptual thing using Kafka Streams, but you have to write it using Java, which will totally suit some people. It won't suit others, which is why you have the choice. So I'm going to skip ahead a couple of slides, and I would like to show you an example of this in action before we wrap up. So let's get through to my appropriate demo slide, and then we're going to have a look at the demo. So in this bit of the demo, we're going to take some data again. I'm going to use Kafka Cat, and this time we're using Kafka Cat to act as a consumer against a different topic. So this topic, it's got a much more sensible set of data in. We've got, instead of just like random ASDFs hitting on the keyboard, we've got a schema. We've got users, and we've got information about stock trades. So a buy or a sell and a particular symbol, an account, and so on. Very common set of data, very common stream of data. And now we want to do something with it. We want to say, I would like to take that and I would like to filter it for a particular symbol, and I would like to know how many transactions have been made for that particular symbol in every 15-minute window. So we're going to break it down like that. So we look at this and you say, well, I've got my stream of data, I've got a consumer, I can pull in all those messages, and now I guess I need to start writing some codes to kind of like work out how to do that. And we're talking about how many within a 15-minute window, so I have to have some kind of persistent store to hold that stateful aggregation, and what happens if my application crashes? How do I rebuild that state and stuff? This is where stream processing comes in. So I'm going to show you ksqlDB. You can do the exact same thing in Kafka Streams if you want to. So let's cancel that, and let's bring up a ksqlDB prompt. So this is ksqlDB command line interface. There's also a REST API. There's a graphical API as well. Sorry, a graphical user interface, if you'd rather. The first thing we're going to do is we're going to create a stream on top of this particular topic. So create stream against the Kafka topic called trades. The value format is Avro. Why are we using Avro? Why is that such a good thing? Because when we create a stream is just a Kafka topic with a schema. Where's our schema? Well, our schema is here. We say describe trades. It says there's your schema. Where did that schema come from? The schema came from the schema registry. This is a perfect example of why schemas are so very useful. Because as a developer, as a consumer, I can now take data from that topic. I don't even know who was writing it. I don't have to go and speak to them. I can say, I've got data on that topic. I've been granted permission to read from it. I can deserialize it. I have the schema. I can now start being productive. I've not had to go and speak to anyone and say, well, where's the wiki with this reference on and blah, 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 blah. I have the data. I have the schema. And because I have the schema, I can now start to interrogate the data. I can project columns. I can apply predicates, select everything from this particular stream where this predicate is met. This is, well, here are those particular trades coming through for that particular symbol. And I could take that and I could say, okay, I'm going to push that onto a new topic. Do this, say, create stream foo as. This is okay, I've created that stream, and that's now populating it with the results of that select statement. And a stream is just a topic under the covers with a schema. Let's say show topics. We've got a new Kafka topic called foo. I can say print foo, so I'm just acting as a consumer here. It says, well, here's your topic called foo. And within that topic called foo, you've just got the values appropriate to that symbol that we asked for. But we also want to aggregate it. We want to say, show me the values for that just particular symbol aggregated up over time. How many trades have there been? What was the average value? And so on. So now we say, we're going to create a table. Streams and tables in ksqlDB and Kafka Streams, separate concept. I can explain it another time or go and look at one of my other talks. And we're going to say, we're going to create this particular table. It's going to hold an aggregate. The side is whether it was a buy or sell. How many trades? What's the total value? What was the average? Broken down by a window of every 15 minutes, a tumbling window. And you have session windows and hopping windows as well if you want to. Where the symbol is this, group by the slide. We've done that. Now we can say, go and tell me about this particular table. So describe that table. It says, here's your table. Here's the schema for it. If we say show topics, we've now got a topic with that data in. And we can also take that data. So let's actually just check the data out first. So we're going to say select star from this table. It says, I've already did that, so do that. So now it says for each time window, and it's using the epoch time for the start and the end here. Here is the total number of trades. Here's the average quantity of the trade. Here's the total value broken down by time window. So we've got an aggregate there stored within ksqlDB. If I had the REST API to hand, I could actually do a query against that, a key value lookup against, for this particular symbol, what's the current number of units that have been sold. Just do a key value lookup like that. But I can also take that, and I can say I'm going to push that down into somewhere like Elasticsearch. So here's where Kafka Connect comes in. Instead of having to write a bunch of code saying, here's a topic, and I'll write some code using the Consumer API and the Elasticsearch API, I'm going to push it down to there. I'm going to take that, I'm going to push it down to here. I'm going to say, show connectors and make sure that it's running. It says, yep, it's running. So it means we can head over to, we're going to use Kibana here as the front end onto Elasticsearch. We're going to say, have we got any data in the indexes, in the indices? It says, yes, you have. So we're going to create an index pattern. So let's do that. We're going to take the data from this particular index. So if you're not familiar with Elasticsearch, it's like a document JSON store. Very, very useful. You can use it for analytics, you can use it for search, and Kibana is a very nice front end that goes on top of it. Because then once we've declared that data, we can say, well, show me the data that you've got in that index. And if we close that, we can say, refresh it every second, show me data for the last hour. So now we can see for each time window, so starting at 10:45, so this is British summer time. So this is an hour back from Oslo, this is an hour forward of UTC. You can see each time window with the appropriate aggregate in it. And if you stare closely at the screen for this one here, the 11:30 one, you'll see those values change. It's refreshing every second, and the data's coming in. ksqlDB is taking that stream of data from Kafka, it's applying that aggregation and pushing the results of the aggregation down to Elasticsearch. And it's doing so with an idempotent key, so it just updates it in place. It's a very, very quick, simple example of what you can do using streams of data, starting off with simple key value bytes, applying a schema to it, taking it, processing it, filtering it, aggregating it. You could do stateful lookups against key values. You can push it down into other systems to use that data where you want to. So let me finish off. I want to quick recap, and then I'll give you some resources as well to go and play with this some more. We'll do questions if time allows, otherwise we'll take it all over to Slack. So we started off with this humble little event. These things that happen all around us, driving our businesses, driving our systems. We said, well, let's just for now call it key value bytes, because that's what things are at the heart. We're going to store them in this log. It's an append-only distributed commit log. We can't go back and change things. Within topic partitions, they're strictly ordered, which is fantastic. We're going to take this concept of the log, and we're going to build around it. We're going to give people ways of getting data in and out with the produce from consumer APIs. We've got Kafka Connect, part of Apache Kafka. We've got Kafka Streams, part of Apache Kafka. So we've got a full set of APIs for getting data in and out, for doing integration, for doing stream processing. We've got a Confluent schema registry, we've got Confluent ksqlDB, additional pieces of the ecosystem that let us build these powerful systems, all built around events, which are kind of like everywhere and which are so very powerful. Hopefully that's whetted your interest in Kafka if you didn't know it already. Hopefully that's solidified your understanding of it already if you did know it. If you want to know more about Kafka, you can go and get these books for free off our website. Go to the URL, scan the QR code. I love logs, I heart logs is a great foundational text for understanding this idea of a distributed commit log and why it's so powerful. Kafka Definitive Guide is a great place to go and really get into the weeds with Kafka. Designing event-driven systems, again, really good for understanding the architectural concepts around this. Hopefully, you want to go and try it out. You can use the demo code that I'm going to share afterwards. You can also go and use Confluent Cloud. So this is the only small little vendor pitch within this. Confluent Cloud, manage Kafka, manage ksqlDB, manage Kafka Connect and stuff like that. You get $50 off your bill when you sign up. There's a code there that you can also use for an additional $60. There's small print at the bottom there. Scan the code, go to the URL. Again, I'll post the links afterwards. Back to the useful stuff, or sorry, it's all useful. Back to the non-pitchy stuff. Developer.confluent.io is a big set of resources for learning Kafka. So there's blogs, there's tutorials, there's podcasts, there's videos. The community hangs out on Slack. So Confluent Community Slack group, go and join it there. There's a ton of different channels for all sorts of areas of Kafka and Confluent platform. I'm off on there. There's a ton of people, both Confluent engineers, a huge number of the community, extremely helpful and welcoming as well. So with that, thank you very, very much for your time. These online conferences turned out they're kind of pretty good after all. So I'm very grateful to Andy for inviting me to speak. I'll head over, I'm at time now, so I won't eat into the next speaker's time, but I'll head over to Slack now, and we can chat to your heart's content all about Kafka. If you want to hit me up on Twitter instead, I'm @armoff. I'll tweet links to the slides, I'll put links to the slides also in Slack. So thank you very much everyone for your time.